In this video for the Exam 3 review, we're going to talk about rational functions. And what we have here is a graph that you're supposed to identify any vertical asymptotes, any horizontal asymptotes, x-intercepts, and y-intercepts. So if you'll recall, a vertical asymptote is a vertical line that the graph approaches. It either goes up to plus infinity, like it does here, or goes down to negative infinity like it does on the left here. So that means there is this imaginary dashed vertical line right there that the graph approaches but never crosses over. And that line is x is equal to 0. So if you'll remember, vertical asymptotes are always x equals, whereas horizontal asymptotes, which you'll see one right here, are y equals. And this horizontal asymptote is y equals 0. The graph does not intersect the x-axis at all, so there are no x-intercepts. The graph also does not intercept the y-axis, so there are no y-intercepts. For problem 9b, same question. We're supposed to identify vertical asymptotes, horizontal asymptotes, x-intercepts, and y-intercepts. And so we're looking for an imaginary vertical line that the graph approaches either up to infinity or down to negative infinity. And when you're given a graph like this, you're really just kind of guessing or estimating. And if I gave you a problem like this on the test, as long as you're close, I'm happy. I usually try to give them at nice numbers. So it looks like I crossed, you know, right here at negative 2 point something, but really that's probably right there at negative 3. So that vertical asymptote, best guess is x is equal to negative 3. Horizontal asymptote, right across here. And again, notice how the red line approaches that line. The red line comes up and approaches this way, and it looks like approaches, see, 2, 4, 6, 8, 10. I've got it crossing right there at 2. My best guess is y is equal to 2. If you put y equals 1 or y equals 3, you could just as easily get this problem correct, because we're doing the best we can just to guess, again, what the red lines are approaching from underneath and over the top. Now, we're looking for intercepts now. So where the graph crosses the x-axis and the y-axis, and I notice actually that's in the same place on this problem, right here. So the x-intercept is 0, 0, and the y-intercept is also 0, 0. For problem 9c, we're asked to find vertical asymptotes, horizontal asymptotes, x-intercepts, and y-intercepts. So we're looking for a vertical line that the graph approaches. So if I do that, my dashed vertical line right through here, it looks like there's one there. It also looks like there's one living right around here. So again, the graph goes up and approaches this way, it goes up and approaches this way, this goes down, and this goes down. And again, there's two of them. So our best guess is it looks like this one is x equals 2. More convinced about that one. This one, it's hard to say. My best guess is x is equal to 5. Okay, as long as you're close, that's good. On the other hand, you know, so here we're approaching this way, and this one goes up and then comes back down. So it looks like we probably have a horizontal asymptote right in here. Okay, what that is, I don't know. See, 2, 4, 6, 8, 10. How about y is equal to negative 4? Again, that's a guess. It could be negative 3. But now, there's something I want to point out here. It is possible for a graph to cross a horizontal asymptote. It will never, ever, ever intersect a vertical asymptote, but it is possible, and it happens right here on this problem, for a graph to intersect a horizontal asymptote, and that's why I gave this problem so you could see that. I also asked for x and y intercepts. So where does this cross the x-axis? It appears, it's hard to see, but it appears that it's 0, 0. I'm not going to guarantee that, but I would certainly give credit for that because that looks about right. And if 0, 0 is the x-intercept, is also the y-intercept. Almost looks like it's over here at 1 as well, so I just don't know without seeing the original function. But as long as you're close, then I'm happy. Alright, for this problem, we're supposed to find the domain, the x-intercepts, y-intercepts, vertical asymptote, horizontal asymptotes, and plot extra points and get a graph. So our function, 2x minus 4 over x plus 2, let's go ahead and start with the domain. So number 1, domain. Remember what you're supposed to do to find domain is before you simplify, you're supposed to set the denominator to not equal to 0. That means x cannot be negative 2. So domain is what it can be. That would be from negative infinity to negative 2, union negative 2 to infinity. So there's your domain. Number 2, the x-intercepts. That's when you set the entire function equal to 0. Now the first step of solving a rational equation is to multiply both sides by the denominator, because you cannot solve for x with it sitting in a denominator. So multiplying both sides by x plus 2, the whole point is so those would cancel. And then on the left-hand side, x plus 2 times 0 is still 0, equals to 2x minus 4. And then I add 4 to both sides. I divide both sides by 2, and I get x is equal to 2. But in point form, that would be the point 2, 0 is my x-intercept. Number 3, the y-intercepts. That's when you substitute 0 in for your x value. So you could say f of x is y, 2 times 0 minus 4, divided by 0 plus 2, gives me negative 4 over 2, which is negative 2. So that's the point 0, negative 2. Fourth thing, vertical asymptote. That's the same as finding the domain, except after you simplify, you set the denominator equal to 0. Well, 2x minus 4 over x plus 2 can't be simplified. You could try to factor the numerator. That would give you 2 times x minus 2 over x plus 2, but still nothing cancels. I'd have to cancel the entire x plus 2 with another x plus 2. So the vertical asymptote is setting the denominator equal to 0, and that gives you your vertical asymptote, which is x equals negative 2. Fifth step, the horizontal asymptote, happens when you look at your cases. So I'm looking at the degree of the numerator, which is 1, the degree of the denominator, which is also 1. Okay, that's 1 over 1. Whenever they match, you do leading coefficient over leading coefficient. So the answer to this would be y is equal to 2 over 1. Again, the 2 from here and the 1 from here. So 2 over 1, or y equals 2 is your horizontal asymptote. Now, from here we need to graph. And so what I want to do is clear the board. So make sure you get all that information, clear the board, keeping the important details like the vertical, the horizontal, x-intercept and y-intercept, and then we'll do a t-table and get this graphed. So I've left all the important details on the right are x-intercept, y-intercept, vertical asymptote, and horizontal asymptote. And the next thing I want to do is find myself an xy axis, which I did. I need to scale it off. This is a good information to help you scale that off. Make sure you have those values on there, and then we'll do a t-table to plot points. And so my scale, it looks like maybe I could go out to 5 in each direction and have a good looking graph. So 1, 2, 3, 4, 5. Okay, and so I have the point 2, 0. I already want to put on my xy axis, and 0, negative 2. Those are my intercepts. And I think I'm going to do in blue a dashed line, or maybe let's do this in a different color. How about purple? Dashed lines to represent my asymptotes. So at x equals negative 2, the graph is not allowed to cross this line whatsoever. At y equals positive 2, the graph may intersect it. So it's okay to intersect horizontal asymptotes, but it's not okay to intersect vertical asymptotes. Now we need to pick some good points to substitute in our t-table. Keeping in mind what you're supposed to always select is between and beyond every x-intercept and vertical asymptote. So if I go from left to right, running across this way, the first thing I'm going to run into is right here at negative 2, I have a vertical asymptote. So I need something to the left of that. And it doesn't hurt to plot a point or two. So let's do negative 3 and negative 4. So I'm going to put negative 4, negative 3, negative 2, again, is my vertical asymptote. Then I need something between my vertical asymptote of negative 2 and my next x-intercept. I do have a point already. It wouldn't hurt to plug in negative 1 as well, though. And then I need something on the other side of my x-intercept, okay? And so maybe 3, or 3 and 4. Let's just do 3 for now, and if we need more points, we'll do that. So what am I doing? I'm plugging negative 4 in for my x in my function. So I'm calculating 2 times negative 4 minus 4 over negative 4 plus 2. Okay, so 2 times negative 4 is negative 8, minus 4 is negative 12 in the numerator, divided by negative 2, so I get 6 as a result. And I'm going to do this for all of these. So 2 times negative 3 minus 4 over negative 3 plus 2 is going to give me negative 6 minus 4 is negative 10 divided by negative 1, so I get 10. I'm going to plug in negative 1. That's going to give me negative 6 over 1, which is negative 6. And I'm going to plug in 3 for my x value. So it's going to give me 6 minus 4 is 2 over 5, or 2/5. Now, nothing wrong with plugging that into the calculator. So 2 divided by 5 in your calculator is going to give you 0.4, 4/10. So let's plot these points. Okay, so negative 4, 6. Would be, notice I cut off at 5, so I'm just going to go up one more. Negative 4, 6. Okay, negative 3, 10. It's even higher. So up here somewhere. Okay, and then we've got negative 2 is a vertical asymptote. Negative 1, negative 6 down here, and then 3.4. About there. So remember, you connect your dots from left to right. Over here, we know we're supposed to be approaching the vertical asymptote and the horizontal asymptote. So our best guess is that this is going to look similar to that. This one is more clear. Again, we're supposed to be approaching the horizontal asymptote. Best guess is that goes up, whereas that continues down to approach the vertical asymptote. So let's try the next problem. B, 2x plus 4 over x minus 2. Notice that looks very similar to the last problem we did, but it is slightly different. So we're going to find the domain. So we set the domain, well, the denominator, to not equal to 0, because we do not want the denominator to be 0. That gives us an undefined, so x cannot be 2. Which means we're talking about all numbers between negative infinity and 2, union 2 to infinity. So your domain should always be in interval notation. Second question, let's find the x-intercepts, which means we set the entire function equal to 0. Okay, we solve this equation by multiplying both sides of the equation by the denominator, which is x minus 2. That cancels. So on the left side we have 0 equals 2x plus 4 on the right. I subtract the 4 on both sides, divide by 2, and that gives me an x-intercept of negative 2, 0. Okay. Third thing we're asked to find is the y-intercept. That's when we substitute 0 in for our x value. We simplify 2 times 0 plus 4 is 4, divided by 0 minus 2 is negative 2, which gives us a result of negative 2 in point form will be 0, negative 2. Question 4, the vertical asymptotes. That is when you simplify first. Now this function will not simplify. You can attempt to factor it just to be sure. Notice there's a greatest common factor of 2 in the numerator over x minus 2, but still this x plus 2 and this x minus 2 does not cancel. So we're left with x minus 2 equals 0, which gives us x equals 2 is your vertical asymptote. Question 5, the horizontal asymptote is when you look at the cases. Notice the degree of the numerator is 1, the degree of the denominator is also 1. Whenever the degrees match, Your vertical asymptote is going to be leading coefficient of the numerator, which is 2, divided by the leading coefficient of the denominator, which is 1. And it's 2 over 1, which gives us 2. So y equals 2 is your horizontal asymptote. So my next step is I want to erase all this information, keeping the important part, and get an XY axis ready to go, and we'll do t-table and plot this graph. Alright, so over here on the left I've put all our important details. I've got the x-intercept is -2, 0, the y-intercept is 0, -2. We have a vertical at x equals 2 and a horizontal asymptote at y equals 2. So I'm going to plot those on my graph. So I've got, again, a x-intercept of -2, 0, a y-intercept of 0, -2. Now let's do an orange. I'm going to do my vertical asymptote of x equals 2, which is this, the imaginary dashed line that we put there to help us graph, and then a horizontal asymptote at y equals 2. So I need to pick some good points to plug in and plot. So I'm thinking we've got to have something on the left and in between and on the right of every vertical asymptote and horizontal asymptote. So on the left of this first x-intercept that it shows up, we need something. So we can either plug in -5, -4, -3, works just fine for me. If you wanted to plug in a couple of points, that certainly wouldn't hurt. And -1 might not be a bad idea as well. Right here, something between this x-intercept and the y-intercept, although not required. You could also plug in +1, okay, and then plug in a point or two on the right of this vertical asymptote, like 3 and 4. Again, that's more than we need, but it never hurts to plug in an extra point or two. So if I plug -3 into my function, that's going to be 2 times -3 plus 4 divided by -3 minus 2. In the numerator, I have a -6 plus 4, which is -2 divided by -5. That's a positive 2/5 because those negatives cancel each other out, which in decimal form is 0.4. Or you can leave it as 2/5. I substitute in -1, and that gives me -2 plus 4, which is 2 in the numerator, divided by -3 in the denominator. So you have -2/3 overall, or rounded, be -0.67, or -0.7. Plug in 1. I have 2 times 1 plus 4. Divided by 1, subtract 2, gives me 6 in the numerator, divided by -1 in the denominator, which is -6. 2 times 3 plus 4, divided by 3 minus 2, gives me 10 in the numerator over 1 in the denominator, which is 10. And then I have 2 times 4 plus 4 over 4, subtract 2. That's going to give me 8 plus 4 is 12, divided by 2, which is 6. Okay, so let's plot these points and see what we get. -3.4, so -3 and almost a half, so about there. -1, I've got -2/3 or -0.7, so about there. Looks good to me. +1, I got -6. That would be here on my scale. 3, I've got 10, which is going to be way up here, really off my page, but I think that'll be okay. And then 1, 2, 3, 4, 6 here. Now remember, we cannot cross this line right here at x equals 2. That cannot happen, okay? So I connect my dots, and it's in two pieces. I got the piece on the left, excuse me, of the vertical asymptote, which is this piece. So you see where those dots connect, and it's going to continue down to approach this vertical asymptote, and this is going to continue up to approach that horizontal asymptote. Then over here, this dips down like this. I didn't mean to miss that point. Okay, let me just make it huge. There we go. But it's going to dip down. It's going to approach the horizontal asymptote of y equals 2 way out here to the right, and then approach the vertical asymptote of x equals 2 going up right there. Okay. All right, so for problem 10, we're asking the same questions as we asked in the last two, and this function looks very similar to the last two too. Notice the subtle differences between these three problems. So we have 2x plus 4 in the numerator, 2 minus x in the denominator. Once again, we're supposed to find the domain. To find the domain of a function, what you should do for a rational function is set the denominator to not equal to 0 or equal to 0, whatever you prefer, and solve for x. So I'm going to add the x over here. So 2 cannot be x. A lot of you would rather have it written the other way. X can't be 2. That's negative infinity to 2 with parentheses. And parentheses, remember, mean that endpoint is not included. So the domain is every number except 2, which we have written there in interval notation. Step 2 is that it asks us to find the x-intercepts. To find x-intercepts of a function, you set the function equal to 0. And that doesn't matter if it's a rational function like we're dealing with here or any kind of function. Now, to solve a rational equation, which is what we have now when we set the function part equal to 0, you need to multiply both sides by the denominator, because you can't solve for an x once in the denominator. So these cancel, okay, and we're left on the left-hand side with 0. 0 times anything is 0 equals 2x plus 4. Now I have a linear equation I need to solve by subtracting 4 on both sides. Divide both sides by 2, and I get the point negative 2, 0 for my x-intercept. My y-intercept, I substitute 0 in for my x value, so I could say y equals 2 times 0 plus 4 divided by 2 minus 0. So that gives me 4 in the numerator, 2 in the denominator, which simplifies to 2, and that'll give me the point 0, 2 for my y-intercept. Next on the agenda is to find vertical asymptotes. Yes, you can have more than one vertical asymptote. This problem does not. To find a vertical asymptote, you always simplify the function first. So that means you need to factor, if possible, and see if any factors will cancel. Well, nothing cancels in this case. I can't cancel these 2's because I'd be canceling part of a sum or an addition, and that's not allowed. I can cancel an x plus 2 if I had another x plus 2, but I don't. So this is as good as this gets, which means to find the vertical, you simply set the denominator equal to 0. I add the x over. That gives me 2 equals x. I could also write that as x equals 2. The fifth step, to find the horizontal asymptote, we need to consider the cases. All right, so notice we have a degree 1 in the numerator, and we also have a degree 1 in the denominator. Whenever the degrees match, it's automatically leading coefficient over leading coefficient. Okay, so leading coefficient in the numerator is 2. So I have y is equal to 2 over, this is tricky, the leading coefficient in the denominator is negative 1. So y is equal to negative 2 when I simplify that. Now what I want to do is I want to take a minute and list all these values right up here beside the requested information. Erase this board and then start fresh so we can do a t-table and plot points. Alright, so I've changed things on you. I listed over here to the left the important information from the last page. Negative 2, 0 is my x-intercept, 0, 2 is my y-intercept, x equals 2 is my only vertical asymptote, and y equals negative 2 is my horizontal asymptote. So I need to put these things on my graph, maybe as a dashed line. Okay, so negative 2, 0 is a point. First of all, let's do our points. That's the x-intercept here. 0, 2, y-intercept here. Now, I have a dashed line at x equals 2. That is my vertical asymptote. And I want you to remember that vertical asymptotes can never be intersected by your graph. On the other hand, horizontal asymptotes are often intersected by your graph. I'm not saying this one does or doesn't, but that can happen. Whereas a vertical you will never, ever, ever cross. Okay? Now we need to plot some other points. Keep in mind, you absolutely must plot between and beyond every x-intercept and vertical asymptote. Even more points than that is probably a good idea. So I'm noticing as I come from the left out here, the first thing I approach is this vertical asymptote at negative 2. So I need to plot something over here. Negative 4 would be good. Negative 3 would be good. I want at least 1 point, but I'm picking 2. Something between this x-intercept and this vertical asymptote would be helpful. We already have 1 point. It wouldn't hurt to plug in another one like 1. Also, -1 wouldn't be a bad idea, although I didn't write that down. And then I need at least 1 point on the other side. 2 would probably be a better idea, but at least 1 point. So I'm going to plug in, there's 3 and 4 available, so let's do both of those, 3 and 4. Where am I plugging these values in? My original function. So I'm doing 2 times -2 plus 4 divided by 2 minus a -4. And I did that wrong. That's 2 times -4 plus 4 divided by 2 minus -4. I got to remember what I'm plugging in. Okay, 2 times -4 is -8 plus 4 is -4 divided by, these two negatives are going to turn positive, so that's 2 plus 4, which is 6, and that reduces to -2/3 or -0.7, okay, whichever you like. Now, I'll plug in -3, that's 2 times -3 plus 4 in the numerator, and then 2 minus a -3 in the denominator. This is -6 plus 4, which is -2. This is 2 minus a -3, which is 5. So that's going to be -0.4 if you type that in your calculator. Okay, plug in 1. That's 2 times 1 plus 4 over 2 minus 1. That's going to be 6 over 1, which is 6. Plug in 3. That's 2 times 3 plus 4 over 2 minus 3. 2 times 3 is 6 plus 4 is 10 over -1, which is -10. And finally, when I substitute for 2 times 4 plus 4 over 2 minus 4, 2 times 4 is 8 plus 4 is 12, divided by -2 is -6. Now let's plot these points and see what we've got. So -4, -0.7. So I'm at -4 and almost at -1, so -0.7. And then -3, -0.4. So that's even higher, almost at a half negative. Okay, and then I plugged in 1 and I got 6. So here's 1. 6 was off my scale a little bit. Right there will be just fine. And that looks good. You know, I can tell what's going on from there. Remember, this graph is divided up into two pieces. There's the piece on the left side of x equals 2, and then there's the piece on the right side of x equals 2. So the vertical asymptote splits it up. So if I connect these left to right, I'm confident that's going to continue up forever, approaching my vertical, and this is going to continue down, approaching that y equals -2 line. Now, on the other side of x equals 2, we plotted 2 points, 3, -10. So this is way down here. I'm going to put a dot right here at the bottom of my page, but honest to goodness, it's way below that, right? Because that would look like it'd be -6. And then 4, -6. So here is really there. So I probably even need to get rid of this point and just remind myself, I'm trying to erase it, remind myself that the graph just continues down right there. Okay, so it continues down like that, and it's going to approach right there. So I didn't really leave myself enough room on this XY axis on the right to get this done, but you can see it's going to go down forever, approaching the vertical, and then it's going to rise up and approach that y equals -2 line. Okay, now the remaining problems, we still have 2 more graphing problems in this review to do. I'm going to do on the next video.